The remainder of this lesson is all about factoring trinomials. And first off, we'll talk about simple trinomials and the patterns that emerge when we're factoring them. So a simple trinomial is generally something that looks like so, where the a coefficient, what makes these simple is that the a coefficient is 1. Now, the patterns that we're going to find and use to solve these actually work just as well if the exponents on your x's happen to be exactly double that. So it would actually also work in this sort of form as well, where you have a to the power of 4 and, the x that's attached to your a coefficient is to the power of 4, and the x that's attached to your b coefficient is to the power of 2. These patterns will work the same as well, and we'll see exactly how that works. And you might remember this as we go along. So to factor these, the pattern that we use is the fact that, well, first of all, what makes these simple is that they have a coefficient in front of their very first term that's just a 1. So what that means is that when we break this up into two separate binomials that will multiply together, each of them has to also have a coefficient of 1. So in other words, we're starting with just an x times another x. And we know that that must be the case because that's the only way that we can multiply two things together and get x squared. So again, what makes these simple is that that coefficient in front of our x squared was just a 1. So we know that each of these starts with just an x, and now we need to find the second piece in each bracket. Well, the second piece in each bracket are going to be two numbers that multiply to give our final term, positive 12, but add up to give our middle term of positive 8. So if you play around enough with the different things that multiply to 12, you'll eventually realize that 6 and 2 also happen to add up to 8. So they fit both criteria. So that is the factored form of what we originally started with. And again, if you use the skills that we reviewed in our very first lesson, you could then expand that out and realize that it's actually just the exact same trinomial that we started with. We've just written it in a new form as two separate binomial factors. Let's try a little more complicated one. So now we've got one that looks like this, and it looks like it's a lot trickier, but look for a certain pattern that's emerging here. So if you see a certain pattern that sort of looks like a simple trinomial, except the middle term has an extra y attached to it, and the final term has an extra y squared attached to it. When that's the case, you can break it down and solve it just the same way you would for a simple trinomial, except that the second term in each bracket is going to have a y attached. So once again, the first term in each bracket is just going to be an x. So I can start this off and set it up like so. And then I'll forget about the y's for a moment and just focus on the negative 28 and the negative 3. So I'm looking for two numbers that multiply to give negative 28, but when I add them, I get negative 3. If I play around for long enough, I would get minus 7 and positive 4, but I'm not quite done. I still need a way to make all these y's work out. Well, it turns out when we have this specific pattern with those additional pieces that I highlighted with the orange lines there, well, all it means is that each of my second pieces inside of the brackets are also going to have that second variable attached to them. So it's just going to be x minus 7y and x plus 4y. And again, if you're a little unclear on why that worked, or if you're not convinced that that has worked out correctly, use the skills from our previous lesson to expand this back out, and you'll realize that you'll get back to the original polynomial that we started with. Let's try one where we may have to common factor first. So now before we do any trinomial factoring with this one, we see that actually all of these terms can be divided by 2, and actually also negative 2. And they all have at least a single power of y. So I'm going to make negative 2y my common factor. Left over then gives me y squared plus 7y and minus 18. And a little bit earlier on, I was saying that when we common factor, it's really useful if you also common factor any negatives that happen to be attached to any of the first terms that you have here. The reason why that was useful in common factoring is because all of a sudden this trinomial that I ended up with inside of my bracket starts with a positive term. And then I can just factor it just like any other trinomial that I'm used to. But I still have my negative 2y coming along for the ride out in front. And this is going to break down into y with something else, multiplied by y with something else. Two numbers that multiply to negative 18, but add up to positive 7. Well, positive 9 and minus 2 would work in that case. And let's see one last one where the exponents are twice what we would normally see for these simple trinomials. So here we've got x to the power of 4 and then minus 10x squared plus 9. So again, it's just like we're dealing with a regular trinomial, except our x variables have double the exponent that they usually have. But break it down the same way. The only difference is that instead of each bracket starting with just an x, each bracket is going to start with double that. They're going to each start with x squared. And that's literally the only difference. So as long as I start each bracket with x squared, I break it down the same way from there. Two numbers that multiply to positive 9, but add up to negative 10. So if I carefully think that through, well, minus 9 and then minus 1 are two that work perfectly for that. But we should always try and use any previous or additional factoring skills we have to factor as completely as possible. And so if we look carefully, you might notice that x squared minus 9 is actually a difference of squares. And if you look even closer, you'll also realize that x squared minus 1 is also a difference of squares. So we can take each of those and break them down even further using the rules that we learned above. So this would become like x plus 3 and x minus 3. Again, you could write those in the opposite order if you want. And then those in turn are also multiplied by x plus 1 and x minus 1. And actually all four of these pieces that we ended up with, once again, could be written in any order as long as you have all four of these pieces, all four of these factors scrunched together by multiplication. For the final portion here, we're still dealing with trinomials, but we're dealing with what we call tricky trinomials. So that's when these trinomials are written in essentially the same form, except that the a coefficient is not equal to 1. And what makes that much trickier is that we can't say for sure that, for example, each bracket is just going to start with x. Like that was something that made this previous example, 3a, that's what made that one much easier, is that we knew that each of our two brackets must start with just an x. But when our first coefficient is not just a 1, we don't know exactly what combination we're dealing with. So we can still try and find different combinations until we find the one that works. It just means we may have to use a trial and error process to actually make that happen. So we actually call this method systematic trial. So let's see what I mean by that. Here we've got 3x squared plus x minus 10. So you can see that our a coefficient clearly is not a 1, it's a 3 in this case. So we're going to do a little process here, and I'll use some space off to the side. It's going to allow us to do a trial and error of different possible values. So we know that when we're filling in these binomials, we have a number that's going to be attached to each of our x's. In other words, a number that'll be attached to each of our variables. That'll sort of be like the first number in each bracket. And then there's a piece in each bracket that's also just a number. So what we're going to do is make a small vertical column to represent different possible factors for each of those options. So for the different numbers that could be attached to my x, well, I need to make sure that when I multiply them together, I get 3x squared. So in other words, the different numbers that are attached to my x need to multiply to give me 3. Well, really the only combination that does that is 3 times 1. And then I have different combinations for my second piece in each bracket. And the different combinations for the second piece in each bracket are things that have to multiply to give me this value of negative 10. So I'm looking for two numbers that multiply to give me negative 10. This is where the systematic trial and error process is going to come in. You may have to try many different combinations. And so I could try 1 and 10 here, or I could eventually try, 10 and 1 here, or I could try 2 and 5, or I could try 5 and 2. But notice every time I did one of those, really all of that would really just be giving me positive 10. So in each of those, I would actually have to try 2 different possibilities. So if I tried, for example, 10 and 1, I would have to try it with negative 10 and positive 1, and then try it with positive 10 and negative 1. So there are lots of different combinations of trial and errors that I'll have to do. Now, I will post an additional video that will show you this in even more detail. So a further note where I'll go through and show even more of my trial and error process and some other examples. But I'm going to, for the interest of time, skip over some of those steps because I know that you can do most of that trial and error for yourself. So I'll just show you how this actually will eventually work. Let's say, just by luck, I try 5 and 2. And I decide that I want to try making the 5 negative, and I'll keep the 2 positive. Now I need to check to see if this works. Well, the check, and maybe I'll just get this out of my way so it doesn't confuse you. The way that I'm going to check this is to do a little crisscross multiplication pattern. So I'm going to multiply 3 times 2 to get positive 6. And I'm going to multiply negative 5 times 1 to get negative 5. And then I'm going to quite literally add or combine these 2 results together and try and see what they get. The key is that I need them to equal whatever the coefficient on this middle term is, or in this case, I need them to equal positive 1. And in this case, because of the ones that I chose, as long as I choose it in this order, I do get positive 1. So this crisscross pattern, I know it might seem a little bit weird and you might not be sure exactly what I'm doing here, but let me write out my final answer first, and then I'll show you what I mean. So to use this for a final answer, really what I've got here is 2 rows. This first row represents my first bracket. My first bracket is going to be 3x's minus 5. My second bracket is going to be 1x plus 2. So let's write those down. 3x minus 5 and 1x, or in other words, x plus 2. So if we think about this for a second, we know that 3x times x gives us 3x squared. Perfect. So we know that one worked out. And the reason why that worked out is because we specially chose these numbers in the first place to make sure that that would happen. We also know that negative 5 times positive 2 gives us correctly negative 10. So that part worked out as well. And in fact, the whole time we were always choosing combinations here that automatically made that happen. But the reason why we had to try so many different possibilities is that we were trying to make the middle term work out to the correct value. So what was it about this crisscross that happened? Well, if you remember, if I was to expand this out, I would not only do 3x times x, and I would not only do negative 5 times 2, I would also have to do, more importantly, 3x times 2 and negative 5 times 1x. Well, that actually, these 2 multiplications that I'm doing are actually the same 2 multiplications that I do when I do this little crisscross pattern. So what I'm doing with that crisscross is testing out different possible outside and inside multiplications and see which ones combine to give the correct middle term. Again, if this process is still a bit weird for you and it's been a while since you've seen it, I am going to post an additional bonus video that goes back to actually your lessons from grade 10 on how to solve these tricky trinomials using this systematic trial process. But let's continue and do a few more of these. So now for this one, once again, I'm going to have possible values that will have an x attached to them, and then possible values in my brackets that will just be regular numbers. The ones that have the x attached to them, well, again, the only combination that's going to give me 5x squared is if I have 5x in one of the brackets and 1x in the other bracket. And then I have different possible combinations that I want to check for -12. Now that's a tricky one because again, there's lots of different combinations that make 12, like 1 and 12, 2 and 6, 3 and 4, but I actually need to make -12, which means I can't just test each of those. I need to test each of them and each of the different combinations where 1 is positive and 1 is negative. So for example, if I try 3 and 4, maybe I try -4 and +3. Well, if I try and do a crisscross there, I would get 5 times 3 is +15, and this one here would give me -4. But if I add those together, I don't get -11. In fact, I get +11, which means I'm sort of on the right track, but maybe I just need to flip things around. So I'm going to actually make this +4 and -3. So what does that give me? Well, that would give me -15 here. And when I multiply those, it gives me +4 here. Now, when I add those together, I do get -11, which is what I was going for. So that means my first bracket is going to be created by this row of numbers, 5x, and then added with 4. My second bracket will be created by this row of numbers, 1x minus 3. So again, 5x plus 4. And instead of calling it 1x, I'll just say x minus 3. And again, expand these back out, and you'll realize you'll get the same result. For C, let's try another one. So now we're going to have some coefficients that are going to be attached to our a's in each bracket. But now this is the situation where we have an extra variable tacked on in a single form to the middle term and in a squared form on the end term. So instead of just regular numbers at the end of each bracket, it's going to be something with a b attached at the end of each bracket. So we're looking for coefficients that will attach to our a's and coefficients that will attach to our b's. Well, again, lots of different combinations we could try. So even for a, we need it to equal 4. So we could try 4 and 1 if we wanted to. But I'm just going to skip ahead to one that I know will eventually work and try 2 and 2. Now again, for the b's, I need them to multiply together to give me 25. Well, again, I could try lots of different combinations, like 1 times 25, but I'm going to try just 5 and 5 and see what that gives me. Let's say I keep them both positive for now. Well, I would get, this would give me positive 10. This would give me positive 10. When I add those together, I would get positive 20. But I actually need to get negative 20. So that's telling me that I must have been on sort of the right track. I just wasn't quite there. I should actually make both of these negative. And then when I multiply that, I get negative 10. When I multiply those, I also get negative 10. When I add them together, I do get negative 20, so that must be the correct combination. So in other words, this becomes the coefficients in my first bracket, and these are the coefficients in my second bracket, which should make you notice a specific little pattern. So we have 2a minus 5b in the first bracket, and our second bracket is 2a minus 5b. So we actually ended up with 2 identical brackets. And our answer there is technically correct, but we always want to make this the simplest possible form that we can write this factored form in. And when we have 2 of the exact same bracket, it's really just like we're taking one bracket and squaring it. So I'm going to write this a little bit simpler by writing it that way. So it's really just 2a minus 5b, and that entire bracket is becoming squared. Let's try one more together, and then I'm going to leave as a final challenge the final 2 for you to attempt and check using the written version of the note. So last one here, now we've got different possible coefficients that are going to attach to our y's, because now it's not x, it's y that we're using. And it'll just be regular old numbers that fill in the other piece of the bracket. So again, I could try 2 times 2, or in this case, I'm going to skip ahead and say, well, maybe 4 times 1 is one of the possibilities that will work. Again, if you want to see more of a complete example where I go through different possibilities in more detail, try the additional lesson on factoring tricky trinomials. But I'm also going to try 2 numbers that multiply to 15. So I could try 1 times 15, but I'm going to try 3 and 5. Now notice if I tried 5 and 3 first, that's totally okay. It just means that I wouldn't quite get the correct result that I'm going to get right now. If I do 3 on top and 5 on the bottom, that's going to give me the perfect result that I want, where I have 20 here, and I have positive 3 here. When I add them together, it does give me positive 23, which is exactly what that middle term is. Remember, that little crisscrossing step is really just checking which combination is going to add to the correct middle term. It's a shortcut for doing that. That's the only thing that we're doing. So now I can say something like, well, it's going to be 4y plus 3 and 1y, or just y, plus 5. So the last two are a little bit more challenging. They still involve factoring tricky trinomials, but the first one, I want you to think about how you could do a bit of common factoring first. So just to clarify, that's question E. Think about how you could do a little bit of common factoring first on this one, and then try and finish it off using trinomial factoring, and check your work using the completed note. For this one, you should be able to do a little bit of trinomial factoring right away, but then see if there's any further forms of factoring that you can break it down into from there. And once again, make sure that you're checking it using the completed version of the note. And as soon as you're done that, make sure that you're trying some homework that goes along with this lesson.